All right, I took again the picture from the book, transferred it here with not as much detail, obviously. So the first thing they wanted to know was H here in this small triangle. Pretty self-explanatory. They gave you basically everything you needed. This is the opposite. This is the hypotenuse. So if we're trying to find H, we're going to use the sine of the angle equals opposite over hypotenuse. Our angle there is 60 degrees, so we're going to do the sine. 60 degrees equals the opposite, which is H over 30. Then we got to look. There's our variable. We want to get rid of the division, so we're going to multiply both sides by 30. So H is equal to 30 times the sine of 60. So we pick up a calculator, do 30 times the sine, 30 times the sine of 60, get 25.98. Again, I'm not sure what they told you to round to. Okay, 2 decimal places. 25.98. And that is in feet. So this is the same as this. So I can transfer that over there. So this is 25.98. Then they wanted to know, what is theta? So they want us to solve for theta, and then they said in terms of d, because we don't know what d is. So basically what they're telling you to do is they want you to use theta, and they want you to use d and 25.98 as your sides. The problem is theta is not inside of our triangle, and we want it inside of our triangle. Well, here's the situation. Let's go back to geometry, people. You have two parallel lines. Here's a parallel line. Here's a parallel line. And they're cut by the transversal. This is the transversal right here. Well, as you know, first of all, this is a right angle. So we know this would be whatever theta is plus whatever that is 90 degrees. But the other thing we know here is that when we have two parallel lines and you're cut by a transversal, the angles on the opposite sides or the alternate sides of the transversal are congruent. So if this is theta, so is this. Which you should have been able to figure out, because if this was 90 degrees, then this would make this 90 minus theta, which means that in order for this all to add up to 180 degrees, you have 90 minus theta, and you need something here that would make 90 plus 90 minus theta plus something be 180. Only thing left to go there is theta. So we have opposite is 25.98. Adjacent is D, so we're going to be using tangent of theta equals opposite over adjacent. They didn't tell us what theta is, but we are solving for theta. They told us that. Equals opposite 25.98 over D. So they want me to solve for theta, which means that if I want to get theta by itself, I have to take tangent and move it to the other side. So when I move from one side to the other, just like I did up here, I had to do the inverse operation, so I have to do the inverse here. So to move tangent over there, I have to do the inverse of tangent. So theta then equals the inverse tangent of 25.98 over D. In C, they want you now to use your equation and figure out what theta, when theta is not less than 25 or more than 30 degrees. They tell you for safety reasons, theta cannot be more than 25 or less than 30 degrees. So what I'm actually going to do is I'm going to find out what this distance is by going back to this tangent equation. First, I'm going to plug in the 25 degrees. That's the smallest value that D can be. And then I'm going to redo that equation, but this time, to find the largest value that D can be, I'm going to let theta be 30 degrees. And then I have to solve this for D, that'll give me my largest distance. Solve this for D, that'll give me my shortest distance. So again, I got to look at this. There's D. It's trapped in my denominator, so I have to get it out of the denominator by undoing this division. So I'm going to multiply both sides by D. So I have D times the tangent of 25 degrees equals 25.98, because the D's canceled. And then I step back and I look at that and I say, all right, now I need to get D by itself, which is attached to the tangent of 25 by multiplication. So I'm going to divide by the tangent of 25. I'm not doing inverses now. I'm moving the whole tangent, which was attached by multiplication. Up here, this was a tangent I was moving. That's why we did inverse. Down here, it's attached by multiplication. Up here, it's attached by tangent. Division undoes multiplication. Inverse tangent undoes tangenting, if that's such a word. So then I have D equals 25.98 divided by the tangent of 25 degrees. So I'm going to pick up my calculator and put that in the calculator. So I have 25.98 divided by the tangent of 25. And again, remember, this is going to be the shortest the distance can be, 55.71. I don't know what they told me to round this to. And these were in feet. And then over here, do the same process. Multiply both sides by the variable. Get the variable out of the denominator. Now get D by itself by dividing by tangent of 30. So we have D equals whatever 25.98 divided by the tangent of 30 is. And we get D equals 44, well, 0.99, but then you have to round up, so it's 45 once you round all that up. So the distance, the shortest it can be is 55.71, and the longest it can be is 45. I said those backwards. The shortest it can be is 45. The longest it can be is 55.71. So that's the interval of distances. The last one, you had to draw a picture here. They told you in words that you had a tower that was 75 feet tall, and that from a distance 50 feet along the ground, the angle of elevation to the top of the tower was theta. So all I did was convert that into the picture. And they want to know what theta is. So looking here, I have opposite and adjacent. So tangent of theta equals opposite over adjacent. Go up there, plug in what I have. I don't have theta. I do have the opposite. I do have the adjacent. Step back, look at the problem. I want to get theta by itself, so I want to move tangent to the other side. In order to move tangent to the other side, I have to do the inverse. So I'm going to do the inverse tangent of 75 divided by 50. 56.3. And that's in degrees, because my calculator was in degrees.